Hello my dear friends, welcome back to our YouTube channel. This is your ADC. So welcome back to our YouTube channel ADC Maths. See the heading, one dimensional wave equation, zero initial velocity, problem number 2. So zero initial velocity, problem number 1 is separate video is there. The same continuation. Let us see this way of questioning. The question sometimes looks like a paragraph, but sometimes looks like a mathematical expressions. Let us see that. Solve ytt is equal to a squared yxx. So what's the mean that? It's nothing but dou squared y by dou t squared is equal to a squared into dou squared y by dou x squared. What is this? This is the one-dimensional wave equation. What is a squared? A squared represents tension of the string by mass of the string per unit length, isn't it? If you solve this one-dimensional wave equation, we may get the required displacement function. We get the required displacement function is a function of x comma t. That's right. Now coming back to the question now. Solve this one-dimensional wave equation subject to the conditions. Sir, this time they given directly the subject to the conditions, boundary conditions are given directly. So this is the second way of questioning, you see, right? So what are the boundary conditions normally for the one-dimensional wave equation? There are 4 boundary conditions, as you know that. There are 4 because a string is fixed at these 2 endpoints. When x is equal to 0, there is no displacement, right? So this is the first condition. When x is equal to 0, there is no displacement function, 0. Second condition for x is equal to L, if it is L is the length of the string. Then at x equal to L, there is no displacement. So there are 2 boundary conditions for x equal to 0 left end, one boundary condition, x equal to L, second boundary condition. So clear? Now, the third boundary condition and the fourth boundary condition for the time factor t. Now, initially time t equal to 0, velocity is 0. So what is the velocity means? Rate of change of displacement. So y is the displacement function. So what is the rate of change? Dou y by dou t at initially the time t equal to 0 is 0. So that's why this comes under 0 initial velocity. So first 3 0 boundary conditions are 1, x equal to 0, displacement is 0. Second one, x equal to L, displacement 0. Third one, velocity is initially the time t equal to 0 is 0. So when we allow the string to vibrate transversely with some initial displacement t equal to 0, y naught sine q pi x by L. So what will be the displacement function of the string during the subsequent motion at any point from one end and at any time t. So that is the question. Clear? Now already we know that the solution, the correct solution of y of x comma t is the correct solution of y of x comma t. What's the correct solution of y of x comma t? Yes, nothing but a trigonometric function a cos px plus b sin px into c cos pat plus d sin pat. Is that right? It's clear. 2 terms for x, 2 for t. By using the method of separation at variable technique, we found that this is the one among the possible and the correct solution since it is in terms of trigonometric function. Yeah. So in this correct solution, when we apply the first boundary condition, what is that? When we apply the first boundary condition, x equal to 0, we get y of 0 comma t is equal to a into c cos pat plus d sin pat is equal to 0. So by this case, we get a equal to 0. When x equal to 0, we get a equal to 0. Now when x equal to L, what happened? When x equal to L, by using the second boundary condition, when x equal to L, y of L comma t, the temperature, the displacement is 0. So by using this condition, we found that the periodic value P equal to n pi by L. Please view the problem 1 video. You can see the explanation for the boundary condition 1 and 2. Third one is the velocity. When we use the third boundary condition, that is the velocity 0, dou y by dou t at the time t equal to 0 is equal to 0, we may get d equal to 0. Now by using the first condition a 0, by using the third condition now d 0, and what about p? P is equal to n pi by L. So let us redefine the required displacement function. Y of x comma t is equal to b into sine. What about p? What's the p, sir? P is n pi by L. So it is n pi x by L. What about c? C is the arbitrary constant. Cos p is equal to, what's the p here? P is equal to n pi by L. So n pi a t by L. What about a? What about d? Both are 0. Both are 0. Right? Now, these two are the arbitrary constants. Arbitrary constants. Let us combine these two arbitrary constants by named as Bn. When you use b equal to 1, c equal to 1, I get one possible solution. When b equal to 1, c equal to 2, I get the second one. b equal to 1, c equal to 3, we get the third one. So it is continued like that. It will create an infinite number of possible solutions. Similarly, by taking b equal to 2, we get c equal to 1, c equal to 2, c equal to 3. So continue like that. So continue like that. This will give an infinite number of possible solutions. So among all possible solutions, let us accumulate all feasible solutions. We will get the most general optimistic solution. Is nothing but, what is the most general solution? The most general solution is nothing but the required displacement function y of x comma t is equal to, by combining all possibilities. So combination means, let us accumulate all the value. Sigma n equal to b, that is n equal to 1 to infinity, bn sin n pi x by L into cos n pi at by L. So this is my required displacement function star. So I apply the first boundary condition, we get a equal to 0. Substitute x equal to L, we get the p equal to n pi by L. By taking the initial velocity 0, we get d equal to 0. So by using these three 0 boundary conditions, in the correct solution, we got the most general solution. Still I have one more arbitrary constant, Bn. So how to determine this arbitrary constant Bn? Here let us apply the last boundary condition. Here at the time t equal to 0, at the time t is equal to 0, what happens? This is equal to y naught sine cube by x by L. This is y naught sine cube by x by L. So if I use the last condition, so finally using the condition number 4, that's fourth boundary condition, y of x comma 0, that means t equal to 0, in the most general solution equation star, we get what we get. Let us see that. What we get? We will get left hand side is y of x comma 0 in the most general solution. By putting t equal to 0, this becomes now cos 0. So cos 0 is 1. Sigma n equal to 1 to infinity. Bn sin n pi x by L is equal to the y naught sine cube pi x by L. See that? This is the given initial displacement function y naught sine cube pi x by L. This is the trigonometric type. Usually what we will do means, we expand this function as the affine sine series. But in this case, it's a trigonometric type. So I introduce some different technique because of it's a trigonometric function. While using the half range sine series, and to determine the constant, Bernoulli formula is completely fails. So we are using some different techniques. What is the techniques? Very simple case, sine cube pi x by L. So how many of you remember the trigonometric identity sine 3 theta? So why I use sine 3 theta, sir? You may have the question, isn't it? Why sir was used the sine 3 theta expansion? Yeah, because of it is sine cube theta is there. So what is sine 3 theta? It is 3 sine theta minus 4 sine cube theta, isn't it? So that's why I use this trigonometric identity. Understand? Right? Now, can we replace these two terms mutually? The left hand side becomes 4 sine cube theta is equal to 3 sine theta minus sine 3 theta. Is that right? Is it clear? Can we divide this by 4 and take it as theta equal to pi x by L? Because in the given data, it is pi x by L is there. So can we divide this by 4 and taking the theta term is pi x by L. So this becomes 3 by 4 sine pi x by L minus 1 by 4 sine 3 pi x by L. And in front of the cube term, I have the y0. So can we multiply the y0 on both these sides? So 3 y0 by 4. So here 1 y0 by 4. So what is this? This is equivalent to this 3 y0 by 4 sine pi x by L minus y0 by 4 sine 3 pi x by L. So this is the equivalent of the left hand side. What about the right hand side? What about the left hand side? Left hand side is the infinite series. If I substitute n equal to 1, what happened? We get b1 sine pi x by L. If I substitute n equal to 2, we get b2 sine 2 pi x by L. If I substitute n is equal to 3, we get b3 sine 3 pi x by L. N equal to 4, we get b4 sine 4 pi x by L. Summation, you know, summation, so put the plus sign between the terms, then this is going up to infinity, is equal to the right hand side is y0 sine cube pi x by L. Now this is y0 sine cube pi x by L, 3 y0 by 4 sine pi x by L minus y0 by 4 sine 3 pi x by L. Is right? Now equating like coefficients, because both these sides now expanded. So equating like coefficients on both these sides. Equating like coefficients on both sides again. So sine pi x by L, sine pi x by L. So this is nothing but the b1 value. So b1 is equal to 3 y0 by 4. I have only one more term, that is sine 3 pi x by L. So sine 3 pi x by is here only. So that means that this is nothing but b3. b3 is equal to minus y0 by 4. There are no sine 2 pi x by L, sine 4 pi x by L, sine 5 pi x by L in the right hand side. It means that all other constants like b2, b4, b5, everything is 0 excluding the b1 and the b3. That means that the most general solution, the constant b1 is non-zero for n equal to 1 and n equal to 3. Understand? For n equal to 1 and for n equal to 3. So here I found that b1 value, b3 value. So let us rewrite the most general solution for n equal to 1 and n equal to 3. What about n equal to 2? b2 0, n equal to 4, b4 0. So everything is 0, so we don't bother about it. So this is the very important concept, using the sine 3 theta expansion for the trigonometric terms. Right, sir? It's clear. Now, can we rewrite the most general solution for n equal to 1, n equal to 3? What we will get? So let us rewrite. Let us rewrite for n equal to 1 and n equal to 3. Because for n equal to 2, 4, 5, everything is 0. So now the required displacement function becomes for n equal to 1, b1 sine pi x by L into n equal to 1, n equal to 1 cos pi at by L. That's right? Plus n equal to, this is for n is equal to 1. This is for n equal to 1. Now for n equal to 3, B3 sin 3 pi x by L into cos 3 pi at by L. Clear? For n equal to 1, for n equal to 3. N equal to 3, n equal to 3, n equal to 3. Now use the B1 and the B3 value. What's the B1 value? 3 y naught sin 2 pi x by L. So is equal to 3 y naught by 4 sin pi x by L into cos pi at by L. What about the B3? B3 is minus y naught by 4 sin 3 pi x by L into cos pi 3 pi at by L. Cos 3 pi at by L. So this is the only two terms because all other constants are 0. Isn't it? Right? So this is the required temperature distribution of the given string. Is the required displacement function. Is the required displacement function. Understand? So this is the problem number 2 for the trigonometric type. For the trigonometric type, y naught sin cube pi x by L. Clear? Thank you so much for watching our YouTube channel. This is your ADC signing off.